Okay, so first of all, let's go back to the idea of on our front page, we had two lines, and we were finding where those two lines were intersecting, right? Okay, let's go back to Geometry Algebra 2. You talked about it in both classes. If we introduce a third variable, we are in free space. This is something you did, I think, exactly a year ago. What does a linear equation represent if it has x, y, and z? You have the right idea. And a triangle, if we extend it out, what do we call that? What did you say? Okay, so it's not a line. Kaylin, your new seat is over there. Where's Kaylin's new seat? Right here. Right there. Talk about what's your pod. It's not a line. It's not multiple lines. Think about something basic in geometry that you talked about with lines. Okay, I've heard it a couple times. I heard it from over here and I heard it from over here. I don't know who said it. It's a plane! Yes. Okay? So once we get into three variables, if all of them are linear, it represents a plane. So we have some options as to what can be happening if our three planes are hanging out. Okay? It is possible, like in number 7 and number 8 on your worksheet, that our three planes intersect at a point. It is possible that our three planes have more than one solution, like in an infinite number of solutions, but it can look two different ways. Okay? If our three planes intersect and they're all the same, we would have an infinite number of solutions. But if our three planes intersect in the form of a line, that would also be considered an infinite number of solutions. Right? There's an infinite number of points on a line. Okay? And then there's two different ways we could have no solution. We could have parallel planes, just like we have parallel lines, but our planes don't have to be parallel in order for them to not have a common solution. They could intersect each other, but not just all three at the same time. Okay? So what I'm asking you to find is the intersection point of three planes. Okay? So like I said, we're going to go through number 8 together. And if you got number 8, awesome. We may do it the same way as you, we may not. Okay? Let's just see. All right. So number 8. Okay? If you didn't do number 8, yay, we did it together. Okay? Here's the deal. On the front side, were you able to solve 2 equations, 2 unknowns? Yes. Okay? Those are what we're probably the most comfortable with. 2 equations, 2 variables. All right? So what I want to do is I want to take this 3 variable system. I want to choose a variable to eliminate twice so that I can whittle this down to 2 equations, 2 unknowns. Okay? Doesn't matter which variable you get rid of twice. It does not matter. It does not matter which variable you choose. Just be strategic about it. Okay? In this case, the only thing I see that would be beneficial here is that we have that negative y right here. Do you see that? And so I think that it would be easy to probably choose y as a variable because we can multiply that pretty easily to get something to cancel out. Okay? All All right. So, which two equations do you want to work with first? The bottom two? Okay. So, what we can do, what would we need to multiply this one by? We would need to multiply this by -2 to make it -14x plus 2y minus 6z equals 0. And then if we use our second equation, you can see that our y's are opposites. That is our goal. We need to pick a variable to make opposite so that when we add these two together, the y's cancel out. We have -9x minus 3z equals 0. All right, I'm going to put like a squiggle under it. Okay, because we're going to come back to that. Now we need to do it again. All right, now we probably should not do it with the same two. We should choose a different set, a different pair. Okay, but we've already kind of mentioned that that third equation is nice to work with because of the -y. So if we choose equation 1 and equation 3, what would we need to multiply that third one by? If I choose equation 1, which is 3x minus 5y plus 5z equals 1, what would I need to multiply this bottom equation y by to make y opposite? -5. It is possible that we would have to multiply two equations by a number to get a variable to be opposite, but today we were lucky and we only had to multiply one equation. Okay, so the whole goal is to get y to cancel out. They do. So we're left with -32x minus 10z equals 1. Agree with that? Okay. There is a lot of room for error in a problem like this, so I encourage you to take your time when you are doing this as to not make a simple arithmetic error. Because if you make one in the beginning, it's carried through all the way. Okay, you can't really recover from it. So now what we're working with, so we have -9x minus 3z equals 0. And -32x minus 10z equals 1. Now we have two equations, two unknowns. What I'd like to do is I'd like to focus on these two equations here, solve for x and z, and then we can use those to go back and find x. Okay? So some of you really like substitution, some of you really like elimination, some of us can do a mix. And I hope that you can be flexible, okay? Because I see that this one, elimination is going to be pretty ugly, but it's set up pretty nice for substitution, isn't it? Okay. This one right here, I have this equals 0. I think it's going to be pretty easy to solve for z, don't you? Okay. If I take this top equation, I can say -9x equals 3z. Which makes z equal to -3. Whoa. Oh, thank you. It's like that is not z. Whoa, whoa, whoa. That was scary. Z equals -3x. That was a lot of work. Okay? So then we can take negative 32x minus 10z equals 1, and we can now solve for x. I don't want you to panic when you get a fractional answer. It's going to happen. Not all the time, but if it happens, it's not an issue. Like, you could get answers that are fractions, and you need to be okay with that. Okay? What do I do with that x equals negative 1/2? Plug it in where? Should I go way back up to the beginning where I have, like, no. We're still in the two variable world here. I need to go back to one of these red equations, okay? Since right here I have solved for z, let's just go back up to here. If z equals negative 3x, then that means z would be 3/2. Okay? Once you get your two equations and you find your two unknowns, then you can go way back up to the beginning. Okay? Doesn't matter which equation you choose. Like, should I choose the first one, the second one, the third one? Does it matter? Yes or no? Okay? It does not matter. Okay? These should satisfy all of them. But let's be strategic about it. Which one would be the easiest to solve for y? In your opinion, tell your neighbor, 1, 2, or 3. Which one would you choose? Okay, so telling your neighbor was like a choral response then. That was nice. Okay, number 3 was by far the most common, or that's what I heard from everybody. So 7x minus y. 7x minus y. What was after that?
Plus 3z.
Plus 3z equals, was that a 0?
Yeah.
Okay. So we have negative 7/2 minus y plus 9/2 equals 0. So y equals 1. Okay. Negative 7/2 plus 9/2 is 2/2, which is 1. Now, I don't want this. We have found a coordinate where these three planes intersect. And I do expect you to write it as a coordinate. Okay. How many of you solved this problem correctly by eliminating a variable besides y in the beginning? What did you eliminate? All right. Okay, let's do a problem that not everyone has done. Okay. Okay, I want you to have a conversation with your pod as you're writing this down. What are we going to eliminate here? Oh, I do not have her. I mean, I have her, but she's not here today. How's that? All right. one, you guys are like on a roll here. What variable or what two equations are you really noticing here?
2 and 3.
Okay, what's going to happen when we combine 2 and 3? Okay, so pod 1 has noticed that in equations 2 and 3, if we add them together, we're going to get two variables to cancel. So if we take 2x minus y plus z equals 3, and 3x plus y minus z equals 2, if we add them together, we get 5x equals 5. All right, well, okay. Have x equals 1.
And then you plug that in for the top. You do first and second, and then plug x equals 1 into the equation.
Okay, so Addison, what you're saying is we need to eliminate a variable again so that we can actually plug 1 into it, okay? Plugging 1 into the equations we have really isn't going to do us a whole lot of good because we have still two unknowns, okay? Now, would it be a good idea to eliminate x?
No.
No, we have x. All right, we eliminated y and z, so we need to pick two equations to eliminate one of those variables.
Well,
Top 2.
could we just plug in the ones for x, and then it'd be y plus z equals 5, and then it'd be negative y plus z equals 2, finding equals 1.
Mm-hmm.
And then we can just write them from there.
Okay, yeah, so what Dallas is saying, could I choose two of those, plug one in for x, and solve two variables from there? Yes, that would be fine. Okay. What the beauty of problems like this is there's so many different ways we can take to solve a problem. Okay, and we can still get to the same answer. Now, what I see is we could combine these two together, right? If I add those together, we would get, so if I take equation 1 plus equation 2, we would get 3x plus 2z equals 9. Do you agree? Yeah. Okay. So from there, this would just be less writing for me, Dallas. From there, we can plug 1 in. To get z equals 3. Okay. Now that we have x and z, we can choose an equation to solve for y. Please choose an equation that is going to be the least amount of work. All right? You giggle, but work smarter, not harder. All right? Equation 1. I bet we can even figure out what y is without even really doing algebra, right? If x is 1 and z is 3, we add the three numbers together to be 6. What's missing? 2. This is a pretty answer, isn't it? Okay. Now, I urge you, or I encourage you to please check your answer. How do we check your answer? Like this. Is 1 plus 2 plus 3 6? Is 2 times 1 minus 2 plus 3 equal to 3? Is 3 times 1 plus 2 minus 3 equal to 2? Check your answer. You will know if you are right. Okay? Any questions on those two examples? Now, this is pre-calculus. We always like to take it a little bit further than what we did in Algebra 2. So far, have we done anything different than Algebra 2? Okay. Please write this one down. Well, there's a Y missing. Okay, so I don't really like the way that I typed this out. But you will see this happen. We want to stack all of our X's together, stack all of our Y's, stack all of our Z's together. So if one variable is missing from an equation, which is okay, it still represents a plane. But I'm going to leave a space there so that all of our variables are still stacked together.
Can you still say that we could just zero y?
If you would like to, that would be fine. If it bothers you. Okay. So which variable should we eliminate?
As first in that.
Okay.
Or you do y, because y's already gone.
Yeah, it's already gone.
Or we could do y because y is already gone in an equation, right? Now you are more than welcome to eliminate x and go through that work twice. But if we have a variable already missing, half of our work is done for us. We can say, all right, in the second equation I don't have a y, so I can take the first and third to eliminate y, and I only have to do that one time. Okay? So over here I'm just going to write that we have 4x plus 2z equals 10. And then if I'm going to eliminate y in the first and third, we would have to multiply that first one by negative 3. Do you agree? Okay. So when we do that, our y's cancel. That was the goal. And we have negative 8x minus 4z equals negative 20. So I am working with those two squiggled equations. You're giving me a look. Okay, so are you saying you would like to use elimination? Okay. If we multiply this guy by 2, we would have 8x plus 4z equals 20. And our second equation is negative 8x minus 4z equals negative 20. But guess what? Our work is not over. Yes, we have infinite solutions. However, we need to express what those look like. Okay? And so here's where we get into some pre-calculus work. All right? First of all, we would know if we had 3 parallel planes because each of our 3 equations would be scalar multiples of each other. So I want everyone to reference your yellow worksheet real quick, and I want you to go to number 4. Do you see how only by multiplying by a number we got those to be the same, right? They're called scalar multiples of each other. If we look at these 3 equations up here, that does not happen. We can't multiply by a number and everything goes away. That would be the case if we had 3 parallel planes, okay? Well, what's our, 3 of the same plane. I said parallel, I meant the same. Infinite solutions means they're the same. If we have a case where we have infinite solutions but they're not all the same, what was our other option? Do you remember? They're intersecting in a line. Okay? So we need to express what that looks like. Now, do we know how to write the equation of a line in 3 dimensions? We do not. Okay? It's really not a thing. Okay? We don't write the equation of a line in 3 dimensions. So what we're going to do is we're going to express coordinates of that line based on a different variable. Okay? So this is what's happening. We can't write that equation, but we can write an expression for how those coordinates should look. Okay, so this is what we're going to do. We get to the point where we have infinite solutions and we know we have that line. right? What you are going to do is you're going to choose one of your variables to equal A. Okay, so what I'm going to do, I'm going to let Z equal A. It doesn't matter which one you choose, okay? Now your answer will look different than mine if you choose X equal to A. Your answer will look different than mine if you choose Y to equal A. But right now I'm going to choose Z to equal A. All right? If that's the case, now, why did I pick Z? Choose one of these variables right here. When you eliminate it down to 2, choose one of those. So if X equals A, then, if Z equals A, then we can go back up here to like negative 8X minus 4. Our Z is now A. Okay. And we can solve for X. So negative 8X equals 4A minus 20. Well, negative 20 minus 4A, whatever. And then we would have to divide both sides by negative 8, right? Okay. So 20 over 8, what does that simplify to? And 4 over 8 simplifies to 1 over 2. So X we would write as 5 halves minus 1 half A. Not pretty. All right. Then we can go back to the very beginning and we can solve for Y. Okay, so our very first equation is 2x. So 2x plus y minus 3z equals 4. What's happening is we are writing each of our variables in terms of A, so it can represent all the coordinates on that line. So what I'm going to do, I'm going to subtract this 5 over to get negative 1. This becomes negative 4A, and then when we would add it over, it will become a positive 4A. So we have infinite solutions where our line would have coordinates that look like this. If I plug in a number for A, I get a coordinate on the line where they're intersecting. That is really our only way to write the equation of a line in 3 dimensions with the tools that we have right now. Questions? When you choose a variable to equal A, should you choose from the 3 variables? When you have your 2 equations, 2 unknowns, when you have your 2 equations, 2 unknowns, I want you to choose from there so it's easier to find the next one. Okay? All of your variables are going to be in terms of A. Okay? For those of you who are getting really tired of graphing, here's some intense algebra for you. Okay? This chapter is very, very algebra intensive. Okay? When you do your homework tonight, you're solving 3 variable systems. And let's do it. Oh, I don't have your gold. I have your gold sheets. I have your gold sheets. Thank you. Okay, it looks like you have 1, 2, 3, 4 required homework assignments, problems. Now, if you don't feel great about like number 5 and number 6 on your worksheet, I have some problems listed that are similar to that. They're not bolded, but if you want more practice, I have them listed there for you. Okay? I can tell you right now that on your quiz, if I give you a 2-variable system, it will not be 2 linear equations. Okay?
Yes. What did you ask? I'm saying yes. Like what?